Hello everyone, welcome to these series of videos that I'm recording for my supply chain analytics class. We'll be talking about the Newsvendor model. This is chapter 12 from the latest edition of the supply chain management book. It's called Growing Supply Chain Using Product Availability. So we'll talk about the idea of product availability, how it relates to the Newsvendor model, what the Newsvendor model is, and things around it. Now, for the students in my class, I am not going to be covering everything in chapter 12, but only the parts that I cover are going to be part of the syllabus. So just keep that in mind. All right. Now, there are a lot of things covered in chapter 12. We'll talk about product availability. There's fill rates and all multiple things that I talked about that we won't get to. I will mostly jump directly to the Newsvendor model, talk about the Newsvendor model, and talk about some extensions of the Newsvendor model, right? That's what we'll be doing this week. Right. Okay, so what is desired availability? What is the Newsvendor model? Now, I call this seasonal inventory management because the Newsvendor model is a model that is used in cases of managing inventories where you have the option of placing a single order. So you can place a single order, and once that order is placed, you will receive the whole order all at once. That's the assumption we'll make initially. And then you either sell everything that you have or you sell some of what you have. You will very likely either end up being backlogged, end up having too much or having too little, right? You'll end up either with an understock, with an overstock, or with an understock. You'll end up with one of those scenarios, right? It's very unlikely that you'll sell exactly what you had. So the question is, these are two opposing forces, and we'll see why these are two opposing forces, and then we'll figure out how do you balance them and how do you make the correct order, right? So when is a Newsvendor model useful? When is it important to know exactly how much product you should have available? What is the desired level of product availability? Well, here are some examples. So seasonal items are very common examples of when Newsvendor model is used. Seasonal items like, say, for example, flowers for Mother's Day or flowers for Valentine's Day. The specific kind of flowers that are stocked for either Mother's Day or Valentine's Day. And for those orders, when florists order from their suppliers, they place special orders. If you're buying sweaters right before the winter season, if you're buying jackets right before the winter season, that's another example, right? So seasonal items. And demand for that will peak in a particular season. So the vendors or retailers who sell these items will have a large order right before the season, so they can sell it to customers as the season happens, and then make the most money. That's the idea behind seasonal inventory management. Now, there are other examples of one-time orders and where the Newsvendor model is useful. Another example of this, let's say that you are printing T-shirts for the Super Bowl. Right. So let's think of a very unlikely scenario where the Giants and the Jets are in the Super Bowl, and you're a New York person and you wanted to, print T-shirts and sell. And you want Giants to really win, so print a lot of Giants T-shirts. Now, whether Giants win, if the Giants win, right, then you will have a very limited window right after the Super Bowl, maybe a month, maybe a month and a half, when these T-shirts will get sold. After that, things will change, right? The camp will happen, trades will happen, there might be coaching changes and all of that. So given all of those things that are going to happen, you have a very short window when you can sell these T-shirts. So again, in one-off scenarios like these, again, the Newsvendor model is useful, right? We will assume that items are continuously stocked, right? And we will mostly look at cases where demand during stockout is lost, not the cases where demand during stockout is backlogged, right? Okay, so like I said, by the end of the season, whatever your season is, you will either have an overstock or you'll have an understock, right? And the question is, how do you value this overstock or understock? So in the simplest case, and that is where we'll start, and we will see how this can be relaxed later on. In the simplest case, you are selling something that you acquire from whoever is selling it to you, right? So we'll say that the price that you're going to sell the item at is P. C is the cost of the item for you. You either manufactured it or you bought it from somebody. That's the cost of the item for you. S is something called the salvage value. So salvage value is once the season is done, once the buying fervor for this particular item is done, how much will you have to discount the item to sell it? I mean, think of chocolates that are sold for Valentine's Day, right? They are put in special boxes, maybe heart-shaped boxes, maybe even the chocolates are heart-shaped. But once Valentine's Day is done, those heart-shaped boxes won't sell as much. So they are sold at deep discounted prices. The same goes for Halloween candy and all the other seasonal items. So salvage value is how much money can you get back? Now, this will obviously be less than the cost of the item. This is true for most cases, because if the salvage value itself is more than the cost of the item, that you are able to sell more, then, well, make as much as you can and sell as much as you can. There is no limits. There is no push and pull in that case. The reason you get a push and pull is because the cost of the item is definitely less than the price at which you're trying to sell it. And the amount of money that you can salvage will always be less than what it costs you. So if you have too much, it's going to cost you something. If you have too little, you're going to lose out on profit. So that's where the push and pull comes in, right? And so the desired level of product availability is based off of something called the service levels. So service levels is when customers come to you to buy something, how often do you have the item available? So that's a service level. And if you, for example, if you run the same business, or if you sell during similar seasons over and over again, out of all the seasons that you sell, how often is it that you will have, you'll be able to meet demand versus times when you're unable to meet demand, right? So that's the idea of a service level. So you can think of service level as the probability that you'll have when a customer comes to your store during the season, what is the likelihood that you'll have items available for them, right? So given this push and pull based upon the cost of the item, the price at which you sell the item, the salvage value, you'll be able to calculate what should your optimal cycle service, or what should your optimal service level be, right? Cycle service level. This service level, again, based upon this push and pull. And based upon this, we will place a corresponding order, right? So we learned this in economics that market is in equilibrium when the marginal revenue is equal to marginal cost. We will do something similar here. So if you have one extra unit left over, right? So if there is one unit left over at the end of the season, if you had one overstocked unit, that cost is called CO, the cost of overstocking. So you had one extra unit. So what is the cost of overstocking? This is the difference between the price that you paid to either buy or make the item minus the salvage value. So this is how much you're going to lose on any item that is left over. So that's the unit cost of overstocking. And the unit cost of understocking is, well, if you had one fewer item by the end of the season. So let's say you stocked 100 items, but 101 people came to your store. So if you had one fewer item, how much profit did you lose out on? And that's the cost of understocking, right? So this is how much you were selling the item at. This is what the cost of the item was. So the difference is how much money you could have made by selling the item. So that's the cost of understocking. So you have a unit cost of understocking and you have a unit cost of overstocking. Now, assuming that we are trying to figure out what our optimal cycle service level should be, and based off of that, we'll calculate the optimal order quantity, right? So the expected benefit of purchasing an extra unit is so P minus C is the cost of understocking times the probability of understocking, right? So CSL is the probability that you'll have items available. That's a cycle service level. So 1 minus CSL, the probability that you will not have the item available. So this is the probability that you will not have an item available times the cost of not having the item available. This is the probability that the item will be available times the cost of having an extra item left over at the end of the season. So if you set these two costs equal to each other, right? So that's the marginal contribution. You basically, if you're setting these two costs equal to each other, you'll be able to calculate the optimal value of cycle service level. So the idea here is similar to the marginal cost being equal to marginal revenue, but and that's essentially what you have. So the cycle service level, so you set the costs equal to each other and you solve for cycle service level. You'll find that the cycle service level can be calculated as the cost of understocking divided by the sum of the understocking and overstocking costs, or in terms of the price, it's price minus cost divided by the sales price minus cost divided by sales price minus the salvage value. So this is the cycle service level. So this sets the value at which the service level that you should maintain. Now, it's not always good to maintain a very high service level, because if you have a very high service level, it means that you have a lot of items in inventory. Now, if the cost of overstocking is very high, then it is not optimal for you to have a large number of items in inventory, right? But if the cost of overstocking is lower than the cost of understocking, then it makes sense for you to have more. And that's basically the idea here. So using this ratio of cost of understocking divided by cost of understocking plus overstocking, we calculate the optimal order quantity. So the optimal order quantity is based off of the cumulative demand distribution. Now, for most cases that we are going to deal with, we are going to use the normal, we are going to assume that demand follows a normal distribution. So assuming that demand follows a normal distribution, this is the inverse of the normal distribution, actually. So in the newer formulas, this should actually be norm.inv, not the norm inv, but anyway. So norm.inv with the cycle service level, mean and standard deviation will be known. So you'll know what the mean of demand is, you'll know what the standard deviation of demand is, and you can calculate that. And then you can calculate the expected profit. So this is the expression for expected profit. It is pretty involved, but and that's how you calculate it. Now the calculation for the expected profit, there is a derivation of how this expected profit is calculated at the end of the chapter. If you're interested, you can take a look at it. It is not a difficult derivation to go over by any means. I'm just skipping over it for lack of time, not because I don't think you have the knowledge of doing that, right? So we can calculate the expected order quantity, we can calculate the expected profit, and we can also calculate the expected the expected profit. You can calculate that. And then we can also calculate the expected understock and the expected overstock. So we know the cost of understocking, we know the cost of overstocking. We can also calculate how much you will understock by the expected understock and the expected overstock. So assuming that it follows a normal distribution, you have specific formulas. If it does not follow a normal distribution, there are these other formulas that you can use, where capital F is the cumulative probability distribution and lowercase f is the derivative of the cumulative probability. It's the point probability distribution, right? So you can assume that you can do this for any probability distribution, but if you're doing it for normal distribution, this is basically how you do it, right? So what we'll do now is, let's go over an example. Now, here is the data here. So what I'll do is I'll stop this video here. We will do the calculation, the example of the optimal service level in the next video. I don't want to keep the videos longer than 10 to 15 minutes. So we will take this exact example. Now, all the calculation is done here, but what I will do is I will do the same calculations in Excel so that you can see how you can easily set it up in Excel and do the calculations, all right? I'll see you all in the next video. Take care.